Hi everyone, so let's do the problem for today, which is minimum distance between BST nodes. To be honest, this is supposed to be the minimum difference in the BST node because I think this title may not be correct. So given the root of a binary search tree, return the minimum difference between the values of any two different nodes in the tree. So here we're given this tree and we're supposed to find the minimum difference between two nodes within the tree. So the best way to do that is by using an in-order traversal, and let's see how we can do that. So here we have our tree, and let's identify what the input and output for the problem is. So the input to this problem is going to be the root node, which is 42613. This is the tree that we just saw, and our output is going to be 1. The reason why it is 1 is because the minimum difference that we can find is 2 minus 1. We'll see that how we find that out in a second. So let's identify what the constraints are to the problem. So the constraints are the number of nodes in the tree can only be between 2 and 100. So at minimum, it can have 2 nodes, and at maximum it can have 100 nodes. And the node value cannot go over 10 to the 5. So those are the constraints to our problem. How we would go about doing this is, let's first understand the tree. So we have 4 as our root node, and then we have 2 as our left node, 6 as our right node, and 1 and then 3 as the children for the node 2. So initially we will initialize a minimum, which is going to be float infinity. We'll initialize an infinity, a minimum variable as an infinity, and we'll also have a previous variable, which is going to be negative infinity. And so we'll also use like node.value, which is the current value that as we traverse down the tree, and then another minimum. So this particular minimum is going to be the minimum that we just saw over here. So when we traverse down, so the approach that we're going to take for this problem is going to be an in-order traversal. So as we do an in-order traversal, when we reach to the leaf node, what we're going to do is we're going to find the minimum at every single node as we do the in-order traversal. So for that, we need to set the minimum to be initially infinity. And then we also have to have a previous value that we set to be negative infinity. And the core algorithm to calculate the minimum is going to be as follows. So the minimum is going to be equal to the minimum of the minimum, comma, the node dot value, the current node that we're traversing, minus the previous value. So this is the actual logic behind finding the minimum difference between two nodes in the BST. So our node dot value. So let me explain as we go down the tree on how this is actually done. So our node dot value at the very beginning is going to be 1 as we do an in-order traversal down the tree. When we reach the leaf node, our node dot value at the very beginning is going to be 1. So initially we have our minimum to be set to be float infinity, and so we're going to find the minimum between infinity and node dot value, which is 1, minus the previous, which we set as negative infinity. So 1 minus of negative infinity is going to give us infinity. So this is going to give us infinity. So we're finding the minimum between infinity and infinity, which is infinity. And then as we go back up the tree by 1, we are going back to the node 2. So our current node dot value is going to be 2. And our previous, we're also going to reset the previous to the minimum that we found, which is actually not the minimum, the node value that we had previously, which is 1. So our previous value is going to be 1 now, and the node dot value at the current position is going to be 2 because we are at this point. And now when we calculate the minimum, our minimum is going to be the minimum between the minimum that we found so far, which is infinity. And so minimum between infinity, comma, the node dot value, which is 2 minus 1, because the previous value is 1. So minimum between infinity and 1 is going to be 1. So our current minimum is going to be 1. Now our next minimum is going to be the minimum between the minimum that we have found so far, which is 1, comma node dot value. So now our node dot value is going to be 3 because our in order traversal is going to be left traversal and then our current route, and then we're going to do the right traversal. So our next minimum is going to be 3 minus our previous value. Our previous value became our current value. So our current node dot value is 3 now, and then our previous value is going to be 2. So 3 minus 2 is going to be 1. So minimum between 1 and 1 is 1. So our current minimum is still going to stay as 1. So far we have found the minimum, most minimum between these 3 nodes, and we know that it is 1. So we have finished the left subtree. So the same process that we did just now, we were going to do it on the right node as well, and then move the most minimum to the root. Then we would bring that back up to the root. So to describe this, I've sort of written this like pseudocode to explain how it is. So initially we will have our base case, and then we'll have a recursive case. The base case is when we hit the leaf node. When we hit the leaf node, we're just going to return our call back. And then on the recursive calls, what we're going to do is we're going to traverse to the left. We're also going to traverse to the right. And in between, we're going to calculate the minimum and then set the previous node to the new minimum. So the code for that problem is going to be as follows. So initially we set the minimum to be infinity and previous to be negative infinity. We start by, we also have to bring in the scope of the minimum and the previous into the helper function. We can also do this by just, declaring this inside a constructor, but I just decided to go with this just to save time. Now, our base case is going to be if node is none, then we'll just return back. And we're going to recurse to the left by calling the helper function on node.left, and then we calculate the minimum by saying minimum of minimum comma node.value minus previous. Previous is going to be reset to the current node.value. So this is what we saw here. The previous at the very beginning is going to be float negative infinity, and then every time. So this is going to be our first previous, and then our current. When our current value is 2, our previous is going to be 1. When our current value is 3, then our previous is going to be 2. So that is how this logic works. And then after that, we're going to recurse to the right, and then towards the end, we would return the minimum. We're going to call the helper function and trigger it with the root node, and then the whole process starts from the top, which is the very root node. And then once the recursion finishes, it's going to return the minimum, which is the most minimum that it has found so far through all the recursion process. And then towards the end, we'll return the minimum. Let's see if this works. Okay. Great. So it does work. So we see that it is efficient, and the time complexity for this would be O of n. And I hope this solution was helpful, and thank you so much for watching, and hope you have a great rest of your day.